Yo, 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 yo. I'm back with lead code. Let's get this done. Okay, let's see what's happening. It's been a while. Let me just. Okay. Oof. Cool. Um. Yup. So. Okay. Close this shit. So yeah, as usual, I'm following the neat code 150. Let's get these things done, man. Given two integer arrays pre-order and in-order, where pre-order is the pre-order traversal of a binary tree and in-order is the in-order traversal of the same tree, construct and return the binary tree. Now this is an interesting problem. Let's see how we can manually do this shit, you know what I mean? Okay, let's see. We have input pre-order and in-order. How can we make a tree out from this? What is pre-order? I know what is in-order, right? In-order is left first, then the root parent basically, and then right. That's in-order. What is pre-order? I think it is the parent first, then left, then right. I believe so, that is the case. So, okay, so I know that root is 3 here. So I can say, yep, 3 is here. Now, to the left of 3, no. What? 3, 9, 20. Okay. How long are these? Pre-order is 3000 length. In order and pre-order length is same. The components, I mean the node values can be negative also. Each value of in order also appears in pre-order. It consists of unique, guaranteed. Okay, so I know that parent is 3. Now from okay. Since no, what? So this is parent left. Now left could be anything, right? Is there any other example? No. I mean left could have been a separate subtree, which would cause a problem here, right? Ah, shit. How do I move this shit? Okay. If left was an entirely separate subtree, it could have caused a problem here in pre-order. So pre-order of this tree would be parent first, then left, then right. 9, 20, right? No. Parent first, then left. Then parent first, then left. Then right. Now this subtree is done. Then we say right? 15, 7. Yep. This will be the pre-order of this thing. How do I make a fucking tree out of these two? Okay. So, okay. I get that 3 is a root, right? Now in order, everything that is in the left subtree of 3 will come before 3. Everything that is in the right subtree of 3 will come after 3. Is that correct? Yes. Now I can do a fucking recursion on left and right, right? What is wrong, brother? Something like that, right? Now, what do I do next? This is I think one of those problems where if you haven't seen it before, you can't write a solution for it. Let's see my submissions. Okay, it's pretty bad. Beats 100%. What the? Okay. So we have pre-order and in order. We take an integer root index. Initially root index is 0. We pass in pre-order in order root index and then 0 and then in order dot size. Root index int left int right. Okay, we're doing left and right here. Okay, if left is greater than right, return null pointer. Look for the root in order. Correct. In pivot equals left, while in order pivot not equals pre-order root index. Root index is 0. Yep. Pivot plus plus. Okay. Root index plus plus. Root index plus plus. Okay, we are moving in here. Okay. Then what do we do? Create a node. Create a node with that parent from in order. Then for left, pre-order in order root index. Root index increases. Okay. Left and pivot minus 1, pivot plus 1, right. Return root. Okay. Root index will be 9 now. That is correct. Is it passed? Oh, okay. It is passed by reference. Interesting. Yep, I get it now. Yep. Now I know that left subtree parent is 9, right? Then I need to recurse on this shit. And I need to keep track of like what root am I working on in pre-order, and I have to pass it by reference so that it is, common among recursions. Makes sense. Makes a lot of sense. Makes a lot of sense, man. It makes a lot of sense. So let's write on our own. So first, what do we have to do? Find root in pre-order. Initially 0 is root. Index is root, right? Now root index is 0. And then we write a fucking recursive. Let's call it, DFS. Now we pass in these two, right? Then we pass in the root index, like at what root am I working on, and then left and right to represent the in order partitions, basically this thing, right? I was close. I mean, I could have gotten it, but who cares? So now let's find the pivot first. Int does pivot start from left, right? While pre-order of root index is not equals in order of pivot plus plus, right? And then at this point we create the node. So tree node root equals new tree. The value will be in order pivot, right? Left and right we don't need. Now for the left recursion, we pass in these two. Root index is increased by 1, right? Now left pivot -1. This goes to right, and then pivot +1 and right. Now one condition to check here is if L is greater than R, then return null pointer, right? What the fuck happened, brother? Okay, return null pointer. Return root. Okay, works on the sample test cases. Let's see the time complexity. It beats 7. I mean, it beats 40%. What is the fucking fastest thing in here? Root left. Yeah, it's the same thing, right? What's this one? Same kind of shit, you know? Why do we need a map, brother? What is map? MP of value to index. Oh. Value to index. Yep, that would increase some speed, but I don't give a fuck, so let's go. Binary tree maximum path sum. Bhai, good. Yes. Epic lead code. Binary tree maximum path sum. A path in a binary tree. Brother, what is it about? This is lead code. Coding practice questions. Questions that are often asked in interviews for software engineering. Yep. That's what it is, brother. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. The path sum of a path is the sum of the nodes' values in the path. Given the root, return the maximum path sum of any non-empty path. Okay. Okay. Return the maximum path sum of any non-empty path. So in here it will be 2, 1, 3, right? Yeah. And here it will be 15, 20, 35 plus 7, 42. Yep. Let's take this example. Now, okay. So we have to do DFS here. Yep. Here sum is 0. Now I can call to left and right subtree to give me maximum path sum. But how do I do that? Now if it is a leaf node, then that is the sum, right? So this will give me 15. This will give me 7, right? And I will return maximum of max of 15 7. No. What? 15 plus 20 plus 7. 15 plus 20 or 7 plus 20, right? That will be the thing, right? I mean, there can be negatives in here, so it'll be 15, 7, 15, 27. Yeah, let's try this. Let's try this. Any repeated things in here? Now 20 is common, right? Bum bum buddy bum bum bum. 15 plus 7. 15 and 7, right? I'll take maximum of these 3. Yep. Okay, let's try this approach. So initially I'll just call int left sum equals max path sum root left. Now if not root, return 0, right? Okay, let's just return max of L sum R sum. L sum plus R sum plus root val. L sum plus root val. R sum plus root val. Okay, it works on the sample test cases. Let's see if it is accepted in here. Wrong answer. -3 or 0. Okay, brother. It could be expected -3. What? Why? Oh, okay. Return int min, you mean? You mean to say return int min? Nope. Shit. Okay, so it'll be 0. But, I mean... Shit. So instead of doing that, should I just do if root, if there is no left and right? Then return root val. Will that prevent this situation? Yep. Okay. Member access within null pointer of type tree node. Okay, if not root, then what? What? Oh. Ah. Okay. Shit. If root left, then do that. Is there any fucking if root right? Let's try this. Okay. 2 -1. -1 minus cannot be represented in type int. Shit. Is there a fucking -1000? Should I just do 0, man? Come on, man. But this will be fucked up because oh shit. Lsum, rsum, lsum plus rsum plus root, lsum, or just root value, right? Shit. Use case bitch. Okay, let's see. A wrong answer. 4 3. What happened here? What? -1. This guess can. So there is no point of including this sum. 3 minus 2 1. What? 3. इसका आंसर क्या है? Expected 3 but given 4. Why? Expected 3 given 4. Expected 3. First of all, how is it 3? How is it 3? 3. What? Expected 3, output is 4. Oh, yes. Yeah, that is correct. Output is 4. Okay. Let's get back on this diagram. Let's take this example. Shit. Now, okay. This will return -1, right? This will return 0, -2000. Or just root value, right? Yeah. Could be 0. Should I do negative 2000? Output is 4. How the fuck? L sum, R sum. Now this will calculate maximum between minus 1, 1, 0, right? A very large negative number and just 1. So it will be 1. This will be 1. Then this will calculate from 1, minus 2, 3, right? And then add them up. 3 plus 1 is 4, minus 2 is 2, minus 1 and then 1, minus 1, 1. So it should return 3 in this case. Oh fuck. Damn. Okay, I got the mistake. Now if this is fucking returning 3, then I can't add this in the yep. It's no longer part of any path through to 1, man. What the fuck am I doing? Now okay. Now okay. In these 3 cases, not even these 3, these 2 cases, these 3 cases, right? I can add more, right? But in these 3 I cannot add more. So I have to okay. Let's do this thing. Let's name it DFS, okay. Let's call it bool can include root. Right? Okay. Now first of all, int alone equals maximum of these guys, right? Together is maximum of these guys, right? Shit. Fuck, brother. Fuck. Fuck. How do I tell the caller? I mean, okay. Now instead of let's return a pair of int and bool, right? If alone is greater than together, then return pair dot of alone and false, else return pair of. Right? What the fuck am I doing? Pair right. Now for a leaf node it will be true, right? Yeah, brother, it will be true. Yep. Now in LSUM, if LSUM dot second is false, if LSUM dot second is false, which means okay, which means the sum that I got from my left subtree is an alone sum. I cannot include root in that. So it has to be either LSUM or RSUM. LSUM or root value. LSUM, root value or root. Okay. LSUM or root value. And same case with RSUM, right? Okay. If LSUM dot second is false, the sum that I got from my left subtree is an alone sum, so I have to compare just if it is false, then I cannot do this shit, right? LSUM, RSUM. Now I have to make like 4 fucking cases, man. If LSUM dot second is false and the right sum is also false, then simply return max of LSUM or sum or root val, right? If okay, now this condition will come in handy 2 more times. If LSUM is false but this is true, then I can do either LSUM alone or I have to know which one I'm spitting out, man. Fuck. Shit. Now if both of them are false, fucking hell, brother. Okay, I can do this shit again. Int alone equals max of L sum or R sum. Int together equals root val. Alone greater than together question mark. Alone false, else together true. Pair in C++. Okay, perfect. Okay, now if L sum is false and R sum is true, I might be making this way too complicated, but yeah, it is what it is, man. Maximum of either L sum, right, R sum, right, or root val. No, 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 no. R sum plus root val, or just root val, right? And return this statement again. Now if this is true but this is false, then we do this shit again. Now instead of in together, instead of R sum, it will be L sum, and yep. I can clean this up. I can clean this up. I can clean this up. We don't need this shit. Dot first. Let's see if this monstrosity works. Shit. What the fuck? No viable conversion from int to pair int bool. What the fuck happened? Oh. L shit. L pair. R pair. L ink. I mean, yeah, lead code is kind of fun, but it's all right, man. It's not that bad. Let's see. No viable pair from int to pair int. What the fuck is wrong? Oh shit! It should be DFS, man. DFS. What? Return alone greater than together? Question mark. Initializer list cannot be used on the right hand side of operator question mark. Oh fuck. Pair in CPP. Can I do a fucking make pair? Make pair. Okay. Oh man. Okay, let's clean this up now. Int alone and together, right? Else if else, right? Else do this shit. I have zero clue if this is gonna work, but I mean, this will be my last try. I'll straight away look at the solution after this if it doesn't work. Okay. Let's see. Okay. Fuck. Output 26, expected 48. What the fuck? 48. Okay, I've made this way too complicated than it should have been, so we see. How the fuck did I do it in one try? What the fuck? Int result equals int min, result return result. If not, root return 0. Left sum, we go left. Max sum, root value plus left sum plus right sum. Maximum valid sum, root value plus maximum of this. Value plus maximum of left sum, right sum, or 0. Maximum of left sum, right sum, or 0. Okay. In max valid sum we can add more, right? In max sum we cannot, right? Result equals maximum of result. So result is global, basically. Max sum and max valid sum. Fuck. This was way too easy, brother. This was way too fucking easy. Shit. I made it way too complicated, and then I pay the price of writing the simpler solution. Max sum will be, max sum is if Bhaiya start a streak series of GFG 160 days or lead code problem from scratch 2 3 questions daily. Start a streak. Okay, brother. I mean, I did a streak previously in the past for 60 days, 60 weekdays. But it gets boring after a week, so I'm not sure if I want to start that again. I mean, I will do like 3 times a week. My consistency is not that bad. Let's see. Yeah, this was my 60-day streak. Now I do like twice a week almost. Yeah, I think twice a week is good enough. Yep. Okay, so max sum is when we do when we can't include further up nodes. So it'll be what? Max of either L sum, R sum, or 0, right? No. What was that shit? Include everything. Okay. Okay. Root val plus L sum plus R sum. Int max valid sum equals root val plus max of L sum, R sum, or don't include anything. What the fuck am I doing? Result equals max of max sum max valid sum, return max valid sum. Okay, I messed up something. Root value plus left sum plus right sum. Right. Oh. Max result, max sum, max valid sum. Max valid sum is root value plus max R sum left sum 0. Max valid sum, return max valid sum. Okay, result equals maximum of result, maximum max valid sum. Oh. Okay, so let's do one thing here. Call this bitch DFS. DFS root return result. What? Oh shit. DFS DFS. Okay, yep. It was kind of hard question, but we understand now. We get it. We get it now. Okay, one more. Serialize and deserialize a binary tree. Serialization is the process of converting a data structure or object into a sequence of bits so that it can be restored in a file or memory buffer, or transmitted across a network connection link to be reconstructed later in the same or another computer environment. Design an algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization deserialization algorithm should work. You just need to ensure that a binary tree can be serialized to a string and this string can be deserialized to the original tree structure. Clarification: the input output format is same as how LeetCode serializes a binary tree. You do not necessarily need to follow this format, so please be creative and come up with different approaches yourself. So one approach is to store a fucking in order and pre-order traversal, and then we can restore the tree as we did in this question. Which one? Construct this question, right? We could do that. What else can we do? Have I done this question before? Of course I've done this 3 years ago. So, okay, I forgot. Let's see what code. Okay, string. Should I just store in order and pre-order? How does that sound, brother? In order, pre-order. Let's see my previous submission, man. I'm not fucking. What happened? Serialize. If root is null, return X. Return toString root value. Return toString root value. toString root value. Okay, pre-order traversal decodes your encoded data to tree construct tree. If data this is X, if data dot size is greater than 1, then data equals data dot substring 2. What the fuck am I seeing here? If data dot size is greater than 1, data equals data dot substring 2, starting from index 2, right? X. Current tree node, get node value data. Current left construct tree data, return current. Bro, this shit is fucking. What the fuck? Who is thinking of this shit? Okay, let's see. Let's take this example. So serialize. If root is null pointer, currently my root is this, right? It is not null pointer. Then return toString root value. So 1 plus serialize root left. Then we go here, right? Root shit. Root goes here, right? then it is not null pointer. Then we add the root value, becomes 2 comma, right? Yeah. Then we go again left. Now this is x, then comma, then we go right, which is again x. Then we go back here, right? Root comes back here out of recursion of the left subtree, then comma again, then we go here 3, then we go left 4, then we go x, then we go 5, and that's it. So this is the serialization of this tree. Now in deserialize, what do we do? Construct tree. We have the string if data 0 is x. Okay, makes sense now. If data dot size is greater than 1, data equals data dot substring 2, because we need to remove this comma as well. So if the string was this, we have to start from here again, right? That's why this is happening. And yep, then current equals get node value data. What? Okay. Now find function, I believe, finds the first occurrence of this symbol, which is comma. So it finds the string which is before this comma. So this, we need to convert this string to an integer. So we do s2i data dot substring 0 to position. We get the value. We store that. No. We don't. We return that value, but we change the data. Pause +1. Correct. Makes sense. We create a tree node. Current left, construct tree. Okay, pretty easy. But is this fast enough? Doesn't seem like it. How lead code serializes a tree? What? Okay. Makes sense. I believe this s2i and this shit is expensive function. Yep, this is expensive. I don't know, but this makes a lot of sense, man. Let's see some other solutions, man, which are fast. C++. Let's try this. Yep, it's the same thing, I believe. Bro, I don't know C++ that well. What the fuck is this? Yeah. So I believe, yeah, strings stream is faster than substringing. I mean, applying operation of substring on a large string, you know, this might be faster. That is why. Let's try this. This will be way faster. I know for sure. Okay. Yep, it is decently fast enough, you know, and if I copy my solution, my previous solution, it'll be slow as fuck because this substringing is very expensive, right? Yep. That is why. Okay, now I need to know more syntax, right? O string stream and I string stream. Serialize return out.str. So it's kind of a string builder in C++. Now in serialize, what are we doing? we are getting the root value and then appending a space instead of a comma. Then serialize root left. Yeah, okay. Then in deserialize we are doing the same thing, but okay. String value in value. Okay, if value is, I believe this thing reads character one by one. So we are putting the first character or the 0th character from in to value if it is bound, which means it is a null pointer, return null pointer, else s to I val. Huh. What? Does it take until they find a space or something? Maybe, because value can be anything, right? Yeah, I think this reads a character until there is a space, right? Let's ask chat GPT. Chat GPT this shit. In CPP, what does this do if in contains attempts to read an int from the stream? Does the operator move the stream until there is a space? Okay, and then tries to read the next value that matches the expression, stopping when it hits something that doesn't match the type or the end of the input. Oh, that's kind of smart, you know. So this operator, okay, pretty good, man. It skips any leading white space. Yep. It reads character until it has a valid int. 1000 is valid, so value becomes it. Then the stream on the next read rem. If you're still trying to extract an int because dollar isn't okay. But I'm. Then it reads characters until the next white space. That chunk of non-white space character gets assigned to val. Okay, pretty good. So let's try to write this down and then we end the stream. So in serialize, stream, right? Out. Okay, fuck this. Okay, so let's write a function void serialize tree node root o string stream out. If root is a null pointer, then out becomes a fucking pound and a space, right? And then return else out gets root value and a space. Right, then serialize root left out, serialize root right out, void deserialize Now in deserialize we have this string, so I string stream in, is it just equals constructor data. Now this is a tricky thing to do. String val, right, in val. Now val contains something. If val is a pound, then return null pointer, else tree node or root equals new tree node s2I val root left equals deserialize root what? Okay, what the fuck is happening? I don't think we need a fucking tree node, brother, here. Like, what the fuck is the point of this? Goes in root right equals deserialize in again, return root, right? Return deserialize in. Oh, my bad, brother. Okay, today we learned new syntax of C++, which will help us probably never again, apart from this question. Okay. Yeah, good couple of lead code questions. I have done this tree list. Tomorrow, maybe, hopefully, I will start digging into heaps, because yeah, this is a good set of questions. Okay, yeah, let's tackle heaps tomorrow, and then yeah, I can get this going. Main things are these four probably. Graphs I can do, I mean, it's not that bad. These two are definitely tricky. This also can be tricky, but it's pretty somewhat straightforward. I don't know. Okay, I'll be back tomorrow, hopefully. Until then, goodbye and take care.